Hello, Namaskara. Welcome to Tech Girl Kannada YouTube channel.
Basic efficiency asymptotic classes indicate the running time of the program is constant. 1. Log in running time takes the logarithmic value. The running time occurs the program that solves the larger problems by reducing the problem size by constant number, that will be log n. N, running time of a program is linear. N log n, algorithms sort elements in ascending order such as quicksort, merge sort, heap sort. These are all n log n. N square, running time of the quadratic sorting algorithm like bubble sort, selection sort, addition, subtraction of matrices. Because there is the presence of two loops. Cubic, and this will be presence of three loops. 2 power n, running time of an algorithm is exponential, Tower of Hanoi. N factorial, running time of an algorithm is factorial. Generate all permutations of the set. Then asymptotic notation. What is this asymptotic notation? These are all the non-negative functions defined in a set of natural numbers. Big O notation, big omega notation, big theta notation. T of n and g of n be any non-negative functions defined in a set of natural numbers. T of n is the algorithm's running time and g of n is some simple functions to compare the count with. That is a basic operation. Informal, big O of g of n is set of all functions with a smaller or same order of growth as g of n to within a constant multiple as n goes to infinity. N belongs to big O of n square. So half n into n minus 1 belongs to big O of n square. This one linearly have smaller order of growth because it is n. But if there are two n's, then quadratic have the same order of growth as n square. Like this, if the answer will be 100n plus 5, it weighs of O of n square. Then both cubic and higher order growth. Omega of g of n is set of all functions with large or same order of as g of n. These are all the definitions of big O of g of n, big omega of g of n, and theta of g of n. If you consider big O of g of n is set of all functions with a smaller or same order as g of n. Smaller or same order. But here, if you consider big omega of g of n, set of all functions with the larger or same order of growth as g of n. Larger or same order of growth of g of n to within a constant multiple. This will be of O of n square n whole. Then big theta of g of n is set of all functions that have the same order of growth as g of n to within a constant multiple as n goes to infinity. Every quadratic function a n square plus bn plus c with a greater than 0 is in theta of n square. Big O of big omega of, one thing you have to remember, set of all functions with a smaller or same order as g of n is big O of g of n. N, big O of n square, big O of n square. Then we have formal definitions, that is, a function t of n is said to be in O of g of n, denoted by t of n belongs to O of g of n, if t of n is bounded above by some constant for all large n, constant multiple of g of n for all large n, if there exists some positive constant c, some non-negative integers no such that t of n is less than or equal to c of g of n. So it will be c of g of n. If t of n is bounded above by some constant multiple of g of n, 100n plus 5 belongs to big O of n square. How big is 100n plus n for all n greater than or equals to 5? So 101n square. This c equals to 101 and not equals to 5 here, which gives lot of freedom in choosing specific values of the constant. A function t of n is said to be in big omega of g of n, denoted by t of n, if it belongs to omega of g of n, if t of n is bounded below by some multiple of g of n for all the integer n. See, if there exists some positive constant c and some non-negative integer no such that t of n greater than or equals to c of g of n for all n greater than or equal to n naught, n cube big omega of n square, n cube is greater than or equal to n cube, like that. Then a function t of n is said to be big theta of g of n, denoted by t of n belongs to theta of g of n, if t of n is bounded both above and below of some positive constants multiple of g of n for all large n, if there exists some positive constant c1 and c2 and some non-negative integers n naught and greater than or equals to n naught. These are doesn't matter non-negative integer. Here it is starts from this, n is greater than or equals to 0. And here greater than or equals to 0 for everything, but t of n is less than or equal to c of g of n, for this greater than or equal to, for this equal. Property involving asymptotic notation. To analyze the algorithms that comprise two consecutively executed paths, theorem, that is t1 of n belongs to big O of g of n, t2 of n belongs to big O of gn of g2 of n, then t1 of n plus t2 of n belongs to big O of max of g1 of n comma g2 of n. Take four arbitrary real numbers a1, b1, a2, b2. If a1 is less than or equal to b1 and a2 less than or equal to b2, then a1 plus a2 less than or equal to 2 max b1, b2. Since t1 of n belongs to big O of g of n, there exists some positive constant c1 for some negative integer n such that t1 of n less than or equal to c1 of g1 of n for this, so that we both inequalities, adding the two inequalities here, c1 g1 of n, c3 g1 of n, then c3 of g1 of n plus g2 of n, 2 max of this. Then hence t1 of n plus t2 of n belongs to max of g1 of n comma g2 of n with constant c and n naught required by the zero definition being 2c3 equals to 2 max c1 comma c2 max of n1 comma n2. If the algo composite of two consecutively executed paths, the algorithm's overall efficiency is determined by the part which the larger order of growth that is lying. Using limits for comparing order of growth. Though the formal definitions of big O, big omega, and big theta are indispensable for providing their abstract properties, it is rarely used for comparing the order of growth of two specific functions. Like convenient method for doing it based on computing the limit of the ratio of two functions, that is limit of n belongs to infinity t of n by g of n. 0 implies that t of n is big O. This 0 or big O implies that t of n is smaller than of growth, big O. Then c greater than 0 is same. Infinity means larger order of growth. Now, boxed approach is more convenient than the one based on the definitions because it take advantages of powerful cellular technologies developed for computing limits such as L-Hospital rule and Stirling's formula.